How long it takes for Twitch to notice that we're streaming. It didn't take long at all today. Cool. Let's tell the rest of the world. Streamin', game dev, building hallways, space hallways, in space. Beep. And then again here. Bloop. So, in the last episode, what we did is we put together the wiring. And, I kind of half-assed it for a long time because I wasn't working with my brain turned on. But today what we're going to do is we're going to create the grid of the spaceship. This is basically a voxel layout in that there are specific sized grids and you're supposed to stick to them. The question is whether or not this is the voxelized layout we're looking for, or whether we would prefer it to have a different grain, because there's no reason that this room has to be considered a 1 by 1 by 1 unit. It could easily be a 3 by 3 by 3 unit. So the advantage of having a different grid is that we can have partially offset rooms. So just as an example, this hallway here, if I put this in front of it, rotate it another direction, so just duplicate this and rotate it. So if I had connected it up so that this was what we saw, and it was in the right spot, like so, you can see how it doesn't really look very good. The hallway doesn't feel like a hallway. It feels like it is just a flat surface. On the other hand, if we have a different size grid, I can do a whole bunch of stuff where I use narrower hallways or something. And in the end, what I can do is I can have this offset by, say, 2 steps, which is, I think, 1 unit or 2 units. That's 2 units of steps. So if I do that, then you can see the hallway quite clearly. So by that logic, I can do some stuff where I make a lot of these rooms have partial offsets. Now, if I was going to offset it completely, it would have to be down here, because I'm actually working with 5-unit high halls, 5-unit high units, as you can see here. This is 5 units, not 3 units. But really the question is what I want this to look like. And when you're using a grid ship, the problem is that it looks like a grid, a flat plane. In order to break that up, I need to take some pretty serious, aggressive action. And there are a lot of ways to do that, but I think that the best way would be to just have these be 3 by 3 by 5, and just have it actually be meter units. That way, I can go and have offsets arbitrarily, and I can just have things that don't quite fit right, and that will create a lot of free space that will make the ship feel a lot more natural. Of course, to do that, we need to take into account that we're going to have different sorts of layouts. So, it's always going to be risky. But a 1 by 1 by 1 voxel grid for these rooms, or I guess we call it a spatial grid. It's not really voxels. It's just keeping track of what room is where. Seems like an easy enough thing to do. So that's what we're going to do. We're going to just create a ship object script. We'll call it a ship map, for reasons that the ship itself might have, like physics and stuff. Seriously? Come on. There we are. And basically the ship map is just going to have a voxel grid. So we're going to just create a set, an array for our ship. Now the question is, when you have an array, where is 0, 0, 0? Because if you can move off in any direction however far you want, then we're going to have to constantly recalculate 0, 0, 0, right? So I'm thinking that 0, 0, 0 will be in the rear lower side of the ship. Hold on, I better close the window. Give me a second. Now, the reason it should be on the bottom is because most ships will have some kind of docking clamp or something at the bottom of the ship, and that's going to be hard-coded into the class, right? And I just won't allow you to make the ship wider than the hard points. So, let me just clean my glasses. I really prepared well before I started this streaming, as you can tell by all of my needs to fix absolutely everything. Right. So let's go ahead and do that. Now, public, why are you randomly showing me crap? I didn't need those debuggers. It's important that your IDE be as complicated as possible while also accomplishing less than it used to 10 years ago. Sorry, feeling a little grumpy about it today. So we have a couple of options. We can do lists, or we can do arrays, or we can do a combination of the two. Now, the reason that we might use different sorts of setups is just for the ease of editing. We're just going to use lists in this case. I'm going to use a list of lists. The other option is to just do a flat single grid. Now, the advantage to a flat single grid is that it's easy to extend, but it's also incredibly annoying if you have to extend it in a different direction. But now that I'm thinking about it, we never do. So let's make it just an array, or rather a list that's just on one axis, or one dimension. So we're going to have that be a list of, we could make it game objects. Let's make it game objects for now. We can always change it later. No, it's going to have to be ship objects. We'll call it architecture. Grid. Of course, it's confused because there is no such thing as a ship architecture class just yet. So let's go ahead and make one. Yunk, blunk. There we are. We could call it like a ship room or something, I guess. It doesn't really matter. But this ship architecture is going to have a bounding box to define it. So that's what we're going to go ahead and create here. Public bounding box, collider. Now there are a couple of ways to do this. One way is we could just take all of the colliders in the ship and create a bounding box based on that. And the other option is we can just take one bounding box that we create. So we'll just do the, we'll just do the one for now. So the problem with this approach is that the bounding boxes, why are you barfing? Oh, of course. The problem with this approach is that the bounding boxes are not in local space, they're in universal space, which means that if the ship tilts, these maps will be wrong. But we're already using world space for a lot of other things, so basically, whenever we do calculations like this, we're going to have the ship at identity, 0, 0, 0, 0, 0, 0, 1, 1, 1. And that's just something we're going to have to live with. It shouldn't be a big deal. This is only stuff that you need when you're constructing the ship in the first place. So, this will allow us to get the bounds of the ship. And over here in the ship map, we're going to be able to link to any number of ship architecture units here in the list. We're also going to need to have a height and a width. So public int width height. So basically, these grids can be a specific cross-section. So in this case, for example, it would be, I think it's 20 wide, and then it would be maybe 10 high or so, enough to give us just a couple of decks if we wanted a couple of decks. So then it can be any length long, but basically every time you add a new length long, you've got to add an entire cross-section to the length. And this sort of juggling is kind of annoying to do. There's got to be a better way to do it, but I've been doing this for 20, 30 years now, and I still haven't found a better way to do it. You still just have to manage the size of the grid. The other option is to do everything in chunks, but it's the same basic idea. You're managing the size of the grid just on a chunkier scale. I don't think there's any advantage to using chunks in this case. So we're just going to create some grid management functions here. So public void extend grid 1z. And then what we'll do is we'll just say for int a equals 0, can we actually just do a grid add range? I don't believe we can just... Sorry, I'm trying to think if there's just an easier way to do this rather than doing an iterator, if I can just do an add range. But the problem is I would need to create an empty list anyway, so there's no advantage to it. There are some languages where you can just say, create 15 of this entry, but I don't think C# is one of those languages. Alas, for int a equals 0, a is less than width times height, a++, and then we just say grid.add null. And then we're going to need a public void assign grid. And this is just going to be us going through all of the ship architecture in the ship and figuring out where it fits into our grid. So to do that, we're going to pop on over into our ship itself. We've got a couple of problems with this basic approach right now. We're using world space for the bounds, but we don't have an offset built into the virtual grid we're creating. The problem with that is that half of this stuff is below 0 on the x-axis or the y-axis, see? And that means that when we are looking at it from the point of view of the ship, we need to have this be at 0 over here, and that means having an offset. So the first thing we need to do is calibrate the offset. But before we can do that, we need to have all of this stuff have some ship architecture. So that's what we're going to do. Shblump. And we're just going to select the rest of these and shblump. Now the ship architecture requires us to have a collider, so we're just going to give these box colliders, and they'll automatically allocate to be correct, and that's fine. The only issue with these is that the door frames are technically not part of the overall setup, and that means that they're going to be a little short. So, we might have problems with that. We'll have to take a look. We can always adjust it if we need to. But these are now set up, except for the small fact that the grids don't have the correct assignment. The bounding box hasn't actually been assigned. So we're going to just create a quick little function to do that. Public void grab local bounding box. And we'll give that a menu. Grab bounding box. And then we'll just say bounding box equals get component. You know what? Why am I doing it like this? I'm being stupid. Sorry. What we're going to want to do is change this out for an underscore. And then we'll just use a getter and a setter. It's a little easier. If bounding box. If not bounding box, then bounding box equals get component bounding collider. Return bounding box. Now the advantage to this is that you'll be able to bounding box equals bounding. The advantage to this is you'll be able to use other bounding boxes if you'd like. You can assign any bounding box you would want, but if you don't assign one, it'll just grab whatever's local, and that should work for most of our setups. It works fine for this. We're going to need our ship to have a specific offset. And to do that, what we're going to do is we're going to create a corner box. That'll be an easy way for us to create the ship volume that we're going to need. So we're going to go ahead and, you know what, the ship map can just be on a sub-object now that I'm thinking about it. So we're going to create an empty here, and we're going to put the ship map on the empty. And the ship map can have a widget that draws the scale of the ship. And that'll help us to arrange it properly. So over here on ship map, we will do a widget drawer. Void draw gizmos. I think it's on draw gizmos. I can't remember anymore. Anyway, we're going to want to draw a grid around our location based on the size of our ship. So gizmos.draw. Oh, we're going to want to have a color, huh? Gizmos.color. No, that's not how you do it. .color equals color.gray. Gizmos.drawCube, wire cube. And we're going to go ahead and have it be at our position. So transform dot position. Now we could have it, we could rotate the gizmo so that the whole gizmos draw in the correct space for our ship. But if we do that, then I guess it'd probably be better. Yeah, let's go ahead and do that. So matrix 4x4 old equals gizmos.matrix. And then gizmos.matrix equals. So here's the thing. We don't want it to be in our space. We want it to be in, yeah, I guess we do want it in our space, so that's fine. Transform dot local to world matrix, I believe. It might be the other one. Doesn't really matter. Whichever one it is, we will get it right. And then at the end, gizmos.matrix equals old. And then in the middle, we will draw our cube. Gizmos.draw wire cube. And then we're going to pick a center, which is just going to be, oh, a center. That's kind of awkward. I guess it's fine. New vector 3. And that's going to be negative width divided by 2. But the width is in integer values, so this is a risk that we might end up with. We want it to go out to 0.5 if necessary, and I'm not sure it's going to do that. We'll find out. Negative height divided by 2 and 0. And then we'll do new vector 3 width, height, and then length, I guess, is what we'll use. We don't have length defined, so let's define it. Public int length equals, or get, return grid dot count. Come on. Oh. Grid dot count divided by width times height. Easy enough. But that will draw just a generic cube, and that should be enough for us to see where our ship is. So let's go back out into our setup and see whether or not our ship map works. It doesn't appear to work. Oh, there it is. So here it is. It's offset by a considerable margin. You can see that I've got the top and the bottom backwards here, but that's fine because we're using a rigid cross section. So by having this, I can edit this to be whatever I want. But you know what? There is a better way to do this. And the best way to do it is to use a bounding box. Now, the reason that it's best to use a bounding box is because a bounding box can be edited like this, which is something that you can't really do. Okay, so I'm not actually sure. You know, editing the collider doesn't appear to pop up any gizmos or anything. Does this actually do anything? Did they break it and forget to fix it when they did the update? I think they broke it and then forgot to fix it when they did the update. Well, in that case, never mind. There's no reason to do it that way. We'll just do it this way, which is pretty typical. We're just going to draw it, and then we'll be able to change the size by doing this. Of course, that's not ideal for the sake of being able to grab it in scene view, but you take what you can get. And basically what we're going to want to do is set this up so that it is just very, very close to the edge here, but we want to be able to catch these units on our ship. They're part of our grid, because otherwise we won't be able to get a good bead on what functional elements are on our ship. Yeah, that's definitely the case. The problem is that these things don't have a specifically defined door, so we're going to have to make sure that we come up with a door as well. So, you know, that'll be fun. So I'm not sure that that's precisely even. I think it's off by 1. So if we take a look here, let's go ahead and see. Yeah, that's at the corner, and that's at the corner? These are shaped differently because they're backwards. That's the problem. Yeah, so those are correct. It's just that one of them is upside down. That's fine. So here we have the basic cross-section of the ship. And we can change the height because the height is really quite narrow at this point. So we'll just make it, you know, a little bit larger, like that. And this is something we can always rearrange later. How easy is that going to be? Of course, it doesn't have any depth yet. So what we're going to have to do is, when we do our scan here, we're going to want to create the depth. And that means testing to see if we are deep enough. That's not too hard. We'll just go in and go through every single object. Nope. There we are. That'll grab all of the ship architecture components in our parent. Why is this barfing? What's wrong with it? Oh, it returns an array. Okay, well, that's fine. We can take it as an array. You think it would underline the other half of the line. Whatever. There we are. So that is us getting ourselves a nice set of ship architecture elements. So first we're going to go through it for each ship architecture piece in pieces. We're going to want to get the bounds of the piece, and the thing we're going to want to know is the maximum coordinate. I think it's the y coordinate. Let me just take a quick little look here. It's a z coordinate. Okay, so the maximum z coordinate. There we are. Oh. Come on, wake up, fingers. If piece dot bounds, or I guess we'll set that float, z equals piece dot bounds dot max dot z. Perfect. If z is greater than max z, then z equals max z. Here's the problem. I think we're actually inverted right now. I think that we are facing the wrong way. Because I believe that this is negative z. Nope, that's the correct way. Never mind. So we're facing the correct way. Good. Here you can see that this gets to be as big as the maximum z value. So what we're going to want to do is make sure that our length is that much. So while length is less than z, then we will just extend grid by 1z. Now the problem is that this is recursive, and if the grid extension doesn't actually extend anything, we will end up causing an infinite loop. Just for testing purposes, we're going to go ahead and break out of this after one iteration just to make sure it's working. This is annoying. I wish I could hide specific warnings. Alright, so we now have the ability to ask this thing to do its job. We got some ship halls and stuff, but these are what's going to really give us the thing, because the z value here is larger than what we've got. So we're going to just assign grid, and it didn't take. See how the grid is a 0 height? That's interesting. That implies that the max z is quite low. Debug.log max z value for ship is, and then max. The reason is because I'm an idiot. Still, it's a good thing we tested, I suppose. It didn't really matter because this wasn't going to cause an infinite loop. There we are. So you can see how that's starting to extend. But we do have this issue where it's extending in both directions. You see that? That's because our center is wrong, so we're going to just change our center. The key here is that the center for the z-axis is actually at half the length, just like all of the others. But it's not at negative half the length. That's because we want it to stop at our 0. Which means that we'll want it to stop right at this pivot point. See? Now, right now, it's not stopping at exactly the pivot point because it is at halvesies. But why is it so big? 21. Oh, I guess it's 21 by 21, so it is pretty big. Is this really the best way to do it? This is getting to be a pretty big list. Maybe it's better to half-ass it. I was going to do this with a list, but now that I'm thinking about it, having a voxelized list like this is really big. It seems inefficient. Okay, so let's scrap this idea. We're not going to do it like this. We're going to do it some other way. I think that the way we're going to do it is we're going to have a pieces list here, and we're not going to worry about this stuff exactly as it's listed at the moment. We're not going to use grids at all. We are going to go ahead and keep this on Draw Gizmos for now. We'll come back to it in a second. But basically, we want to make sure that all of our setup is functional. So we're going to go ahead and have this... yeah, hold on. Sorry, I'm trying to think, and it's being a little faster than I want, so my brain. Except I already learned that that's not going to work because it actually gets an array. I could have sworn it got a list. I'm not sure why I remember it wrong. If pieces.length equals 0, or if there is no pieces. Return pieces. Here we are, and that should allow us to fetch all of the pieces. And so what we're going to want to do is have a public bounds, underscore bounds here, and then we're going to have a public bounds. So this bounds is going to get the other bounds. The problem is we don't really know how big the bounds are. So if bounds.extents.magnitude equals 0, then we're going to recalculate the bounds. But we're actually going to have to do some functions where we reset both the bounds and the ship pieces. So up here, when we grab all the pieces, we're going to have to reset the bounds too. So in here, what we're going to do is we're going to go through all the pieces. For each piece, ship architecture, piece in pieces, we're going to want to add the bounds of that piece to our bounds. Bounds.encapsulate, and then the bounds of this architectural piece. So piece.bounds. But there is one thing we want to do. The very first time we want to have it, well, you know what? We can just center the bounds. As long as the center of the bounds is somewhere valid on the ship, it's fine. But if the center of the bounds floats off of the ship because you've built a really long ship and then you unbuild that ship, then refreshing the bounds could leave it with a center that counts as a point that should be in the ship even though it's in front of the ship. So we're going to reset the bounds so that that doesn't happen. There we are. That should get us the bounds of the ship. And so down here what we'll do is we'll draw a wire cube and we'll pass it the bounds. Can we just pass it bounds? No, we do have to specify. Bounds.center, bounds.extent. There we are. So with that in mind, we should now be able to do things, but we are going to want to, well, I guess we can clear it manually. It's fine. So we go over here, scale in and out for a bit until it barfs. There we go. And you can see how the bounds that it's calculated are not valid. And that's because they are in world space and we translated them into local space. There we go. So those bounds aren't correct. Why aren't those bounds correct? Because these are so much wider than that. The bounds for this go all the way out to the edge. So why is this not working? Grows the bounds to encapsulate the bounds. That should work. It's worked in the past. Why isn't it working now? Why don't we go ahead and just make the bounds equal to a new bounds? Still, I don't know what's going on here. Debug.log, bounding, and then plus piece.name plus comma plus piece.bounds .extents. We're going to have to reset this, I think. So to reset it, what we'll do is we will just set this back down to 0, and it should pop right back into full size. No? That's interesting, because that should work. Okay, that was a little strange. Oh, I see what's going on. That's fine. I can work with that, but I can't work with this broken bounds. What's going on here? Why is this... So here you can see that the bounds of these things are reasonable. If we take a look here, bounding box on the solar small is 13 by 3 by 2. So that's right, 13 by 3 by 2. That's actually kind of small. But either way, when we look at it here on the box collider is twice that size, which is correct. Because those are the extents of the bounds. All I can think of is that the center of the bounds isn't working. Is that what's going on here? This is strange. So when we look at that, we got the center of the bounds, and you can see that the center is correct. It's negative 23, which is over here, or rather over here. So that's fine. So the question is, why are our bounds not working? Our bounds aren't even actually extending to cover the center of those bounds. Extents of 37, really? And if I scale this up, it doesn't change. So what's causing this to have such a weird set of bounds? You know what? Let's go ahead and make it so that it only takes the very first piece, because that'll tell us what's going on. So when we do that, what we'll end up with is something that should only contain the small rocket. Okay, so here we are. These are our bounds. Oh, extents. I see what the problem is. I'm drawing them wrong. Curse you, draw wire cube. You should take the same arguments as bounds. There we are. So now, if I go in here and I fix that. So it was working the whole time. That's the short answer. My visualization was just bad. Brilliant. There we are. So as you can see, it now does bounds correctly. And it will continue to do bounds correctly as we move forward and incorporate these other devices. They don't have any pieces yet. That's the thing. So we need to give them new components. They all need to be ship architecture. And that will allow us to create them in a much more clever way. Now the problem is that the ship architecture needs to have a doorway or multiple doorways so that it can work. And in order to do that, there needs to be a doorway object which is centered around where the doorway would be. And in this case, we can do that quite easily because they actually have door frames. And all we really need to do is make sure that the door frame is correctly set up. You can see that in this case, what we've got is we've got a door frame that is rotated 90 degrees. And that's because of the way that I built this. I wanted to put it together like that, and the result is that we have a rotated doorway. Basically, however, we don't want the door frame center to be at the bottom of the door. It might seem like that's a good place for it, but in our case, we want it to be in the middle of the door. And the reason for that is because if it's in the middle of the door, then this kind of rotation won't cause a lot of problems. And we'll probably end up using a more round door to hide this sort of mismatch. But for now, all we can say is that this isn't the door. There's going to be another door. So what we'll do is we'll create the bounds. We'll just create a door object. That's what we'll do. Ship door. And then what we'll do is we'll draw the ship door as something we can see. So that's not too hard. We'll just go ahead and draw a widget. We really probably should draw something other than a gizmo, but that's fine. We'll just draw a gizmo. Void on draw gizmos. And what we're going to do here is we're going to adjust this so that it has the correct setup. So gizmos.color equals color.yellow. Gizmos.matrix equals transform.local to world, or was it the other one? Matrix 4x4 old matrix equals gizmos.matrix, and old gizmos.matrix equals old matrix, and we're going to draw a frustrum, I think. Gizmos.draw frustrum, and we're just going to start at the center, which is just going to be at 0, 0, 0. We're going to have a FOV of only like 25 or 30 here. It's not a big deal. The max range will make 5, and the min range will make 0, and the aspect is just 1. So I'm not actually sure whether or not this is going to work, but I thought I'd give it a shot because I have a vision in my head of how things should work. Of course, we can't tell yet because I haven't added one, but we're going to have to add them in as new objects that are on this object. It would be a decent place for them. And we're going to just pop it up so that it's in the middle of the door, which is right there. You can see that it is rotated in the wrong direction. So if we rotate it to the correct direction, like that, there it is, local pivot. So we actually want to go along the z-axis, and this is why it's important for us to use a frustrum, because if we use a frustrum correctly, we can actually get the directionality of the door when we're drawing it. The problem with this is that I've currently got it so that it's starting at like a point there, and we really don't want that. So we're going to go ahead and make this like a vector3 dot back times 5, and we'll just see how that goes. So I think that what we can do is we are trying to get this to be a specific size. So if we just use a combination of length and FOV that gets the size we want, we should be able to get this to work more or less perfectly. All right, so in this case, it looks like I accidentally went the other direction. So hold on, what did I do wrong here? FOV, max range of 5, min range of 10. Well, there's the problem. So max range of 15, min range of 10. This doesn't seem right. Am I misunderstanding something? Because if I'm putting it 10 meters behind me and telling it to start at 10, shouldn't it? You know what? I think the center isn't actually at the 0, 0, 0 point. I think the center is the start of the actual object. Yeah, okay, so that's what I was misunderstanding. I thought that the center point was where all of the lines connected, but it's actually where the frustrum starts getting drawn, which is a much better call for me. It's much easier. So we're just going to have this be like 14. And that should be exactly what I wanted. Nope. Wow, this is not working out. What the heck? I think I got some of these values backwards. Min range, here it is. This should be 10. That's what I wanted. I just got to remember which argument is in which position. Really? Why is it insisting on being this long? Can't I get a short frustrum? What the hell? I'll just draw a box. I'll master Frustrum someday. So here you can see that we can't tell which direction it's going, so we're going to want to offset this. There we go. And I think that we're going to want to have this, so... Yeah, something like this might be pretty good. Yeah, perfect. That'll do for now. We don't need to go overboard with it, although it's been a little bit too late. I've already gone overboard with it. Still, better than the alternative, I suppose, of not being able to tell what the heck I'm doing. For now, we're just going to delete this other guy. And we need to basically make this door for all of these. So here's another ship object. We can just drag it back here and then put the door in. You can see that the door that's built into this has the wrong scaling factor. Now it's correct. And if we were to paste this in, you can see it's nowhere near being in the right position. So we'll just zero this out. And it's pretty close. This looks like it's at 0.5. That's interesting. Why is this offset by some strange amount? The door frame should be at 0, 0. Oh, the door itself is wrong. There we are. That's better. So you can see that there's something wrong with this. It's off. It's in a 0.25 area, which it shouldn't be. I guess we'll just leave it like that for now because I don't like the idea of it being offset by 0.25. Apparently, when I modeled it, at some point I offset it by 0.25. That was not bright, but what can you do? I'll remodel it later. So now we've got some doors, and we can add doors to all of the objects that need doors, including these guys. So we'll just keep doing that. There we go, another door. And we'll stick the solar back in where it was. There we go. And we'll just delete the other solar, and then we will reset the ship. We're going to want to have a reset button for the ship, so let's go ahead and make that. And the way we're resetting it is we're just going to say pieces equals null, and then we're going to say bounds equals bounds.extents equals vector3 bounds equals new bounds. There we are, and we'll just give that a menu. And that way we'll be able to reset this without having to do any weird fuddling. And you can see that it only contains the new pieces that actually exist. Now we do have doors now, and that's a very valuable tool for actually hooking things up. And the next step is to make these hallways do their job properly. Now the problem with the hallways as they stand is that they don't actually exist. They are not properly set up to be ship objects. The question is whether or not hallways should even be a ship architecture component or whether it should be something else. I think we'll leave it as a ship architecture component, but we're going to need to rethink a little bit how we define this. It's not going to be the default ship architecture component because it has to be more adaptive than that. So we're going to have an adaptive ship architecture component. And this is going to be descended from ship architecture. There we go. And the idea of an adaptive ship architecture component is it will be able to tell if there are doors off to the sides. and then it will be able to switch out the elements that are off to that side with a door object, a door mesh. So to that end, we're going to want to have a stored game object, a stored prefab, that is the door mesh. So public game object door mesh. And then we're also going to want to have a public transform sidewall left and sidewall right. Maybe this isn't how we're going to do it. I haven't really thought that far ahead, but this is the basic idea. Now the question is, these hallways have directionality, and currently I'm running them left to right. However, in reality, they were built to run along the length of the ship. So if we were going to do that, what we might do is take these two hallway windows, put them inside of their own distinct object. So we're going to create a hallway object here. And then what we're going to want to do is make sure that these things are both lined up, and you can see how they're both 0, 0, 0, just at different rotations, and that's exactly right. So what I was trying to say is that these really should be aligned like this. Because they're intended to run along the length of the ship. But that said, I actually don't want them to look like this. And this is the part that is a little bit difficult for me, because I want them to have 6 or maybe even 8 different edges. This window edge is one that you might use to when you're facing the outside of the ship, and it looks good from the outside. So you're out here, you're like, oh, look at that window. But when you're on the inside of the ship, the window is pointed straight into another room. So for the inside of the ship, I would want a flat surface. Similarly, when it comes to doors, I'll need a door frame that goes off to the side. I guess I don't need a different door frame. So I need 3 different wall meshes. I also need to have the door module. So side door mesh and front door mesh, final door mesh, cap door mesh. And then we're going to want outside mesh and inside mesh. There we are. That's what we want for our for the game objects that we can replace this. The other thing we're going to need to do is think about whether or not we need to have a game object set aside for the door caps. So let's go ahead and do that, yeah. There we are. So those are the 4 transforms we're going to need to make this work. And what we can do is put the game objects inside those 4 transforms. And really the 4 transforms are just slightly rotated empty transforms. It's great. But first we need to model that stuff. This is not quite the model I would like, so we're going to just pop over into our ship halls, and model ourselves up some new hallways. So the basic idea with these hallways is that they're split down the middle. And we're going to want to have it so that they are roughly the same shape as the door. But basically, I think all I need to do is model one more thing. This is going to be the hall half window. We're going to need the hall half bulkhead. So we're going to just duplicate the window and bring it on back. And then we're going to transform it into a bulkhead, which is a relatively easy thing to do. We just want to get rid of this. And then get rid of this whole inner section, really. Like that. And then we will just connect the edges. Not bevel. There we are. But to make this feel a little bit more bulkheady, we're going to go ahead and put in just a little bit of bracing. We have to be careful how we do this because the door cap still has to look right. But the way we can do that is we can actually break through the door cap and overlap it in the other direction. We have to be careful about this, though. I'm not sure. I do know that this is backwards, though, so there we are. I might just... Let's go ahead and see how it looks if we stripe it. So by striping it, I mean that we will leave a cap there. And the reason I say striping it is because this will actually end up creating a bumpy result. So if we were to extend this like so, for example, and then if we were going to have several of these in a row, it would look like this, see? And I'm not sure... because the alternative is Z-fighting. Let's go ahead and try and Z-fight without too much damage here. So basically, if we get rid of this line that we created, the idea here is that to minimize Z-fighting, what we'll do is when we make this a larger object, we'll make it a larger object in a curve. So if we do it like this, for example, then we won't end up causing any Z-fighting because it comes out a little bit further. Now the problem with this is that it is going to cause us issues over there, but if we scale both the edges at the same rate, it should work out. The only question is, can I bevel this and have it still look good? If we bevel it, it's going to create a crease. Whereas if we don't bevel it, it's going to create an overlap. This is a challenge. Of course, we also have the problem here in the middle. Okay, so this isn't going to work. We're not going to be able to do it like that. We're going to have to do the stripe. There's no realistic alternative if we want to keep this integrating into the rest of the hall. So let's switch over into active element mode. And then we will just extrude here. And then we will scale Z0. And then we will just merge all the doubles. And then down here we will do the same thing. And that'll give us a very, very square object, as you can see. And then just to make this a little bit nicer, we'll just bevel some of this away. So just grab these elements and we bevel them until they can't be beveled anymore. We'll get this. And then if we put in a little bit of a... I'm trying to figure out what the best way to do this visually would be. No, that's not going to do it. Well, for now, this is fine. We'll just put in a little bit of a dent on the side so that it feels a little bit more natural. And we're going to call that the wall. So this is a hall half wall. And this is a hall half door. And those things combined work fine together. The question is how good they're going to look. I really want to do a much more exaggeratedly off-center hallway set, but I think it will have to wait until my next iteration because I would have to completely start over. And that's not something I want to do on camera, really. I'll just wait a little while longer. But before I can do these things, we're going to need to have a couple of hall elements. And the hall elements we're going to need are going to be the hall half window and the hall half door and the new hall half whatever the other thing was. So we're just going to go ahead and stick those into our prefabs list. And the key here is that they're going to be rotated not at all. So that's the hall half door. Here's the hall half window, which we will get rid of the 6 and then put that in. And again, it's not rotated at all. And then the last thing we're going to want to do is a hall half wall, which is the same exact setup, but with the new hall half wall. And then that will be what our hallways are made out of. So here is one of our hallway objects. And this will have the setup that we need if we start to establish it. So, right, I never saved the door. Here it is, hall door. So we're going to go ahead and drop the hall door into the same prefab section. And as with the others, it is unrotated and unmoved. So, what we're going to want to do is just fill in the values that we need and call it ready. We are also going to want the hallway to draw itself a bounding box of some sort. Maybe it's okay if it doesn't. The problem is that once I get rid of these meshes, it's going to be invisible. And I don't really want an invisible hallway. Maybe I'll just have it draw like a quick little 1 by 1 by 1 box or something. Void on draw gizmos. Gizmos.draw. Draw box, draw cube. We're not going to draw a wire cube, we're going to draw a real cube because it's going to be smaller than the hallway. So transform.position and then vector3.1 times 2. I think that the hallway is split. Close this down. I think the hallway is spread in both directions, so I think that's fine. Oh, come on. That was weird. So you can see how inside is now a little hallway thing, but the hallway is actually at 0, 0, 0. It's at the bottom, the z-axis of 0. So that's interesting, because that means the doors are all going to be off-center. I think what we'll want to do is move these down 0.5 or a full. I think it's going to be a full 1. Yeah, that's it. There we are. Because otherwise we won't be able to easily line up with the other doors in the area. So there we are. We're all set up for the sides now. So these aren't really the things that we're going to have, but it's important. I don't know why there's a random game object inside of this window. I must have done that meaning for it to be something, but then didn't finish. So the hall half window is going to be the sidewall left and the sidewall right. I actually don't know which of them is left and which of them is right. This is left, so 5 is left. So I got them backwards. That happens. Left. Right. And then we'll just turn off the mesh renderers for now. We'll come back to that later. But since this has directionality, I think what we'll do is we will have this be longer so that we can tell which direction it actually goes in. There we go. So now that we've got this hall, we just want to be able to tell it to do its job. We have to set it up to be able to do its job. Here are the hall elements. This is the hall cap door. This is the hall side door. This is the hall side window. Nope, that was the wall. This is the window. There we go. And there's no bounding box for this right now. Let's go ahead and just add a bounding box. And we'll make it 2, 2, 2. I think it's going to have to be 3, 3, 3, right? That seems like it's not quite right. Am I using 5 by 5 grids? I thought I was using 3 by 3, but if I'm using 5 by... That's too big. So am I using 4 by 4? What's going on here? That's interesting. Oh, of course I'm using 4 by 4. So yeah, I'm using 4 by 4 grids. So that's the bounding box of the actual hallway. And what we're going to do is we're going to look for things that are to the left and to the right and make sure that we use the right objects for them. So that means deleting this hallway because it's kind of not where it's supposed to be. There we go. And putting this hallway over here. And that should be able to detect the doors to the sides. The only problem being that it's not offset the right amount to line up. So we'll just fix that. And that should be more or less lined up, I think. Ooh, not even close. All right, so now now we have to have this able to actually grab it, set itself up. So public void setup. And this is going to have to be a menu item. Come on. There we are. So when we have this, we're just going to go ahead and take a quick little look and see whether there are any doors in the ship. And the way we're going to do that is we're going to ask the ship map. How we find the ship map is a little bit of a concern because we've got the ship map off in its own object, but it shouldn't be. The only reason it was off in its own object is because I was trying to do something clever, and I don't need to do something clever anymore. So now we'll just drop the ship hulls inside the ship, and everything should be hunky-dory. We can just go ahead and go back over to the ship architecture and have it be able to grab the ship map. Return get component in parent ship map. There we go. So now what we can do is we can ask for all of the doors by going over to the ship map and asking it for all of the doors. Right now the ship map doesn't have the ability to grab the doors, so we'll just go ahead and add that in. My fingers stopped working, so I guess it's probably time to stop streaming, but I want to finish this. If doors equals null or doors dot length equals 0, then doors equals get components in children ship doors. We're also going to want to get rid of this part. Oop. Perfect. And return doors. Down here in the reset, we're going to want to clear the doors as well. There we go. Perfect. And so when we want to have our adaptive ship architecture find the doors, we'll just grab them. So ship door doors equals map.doors. And then what we'll do is we will search for doors that border us. Pretty straightforward, right? And that's a very straightforward thing of going the correct amount off to the side. But you know what that means? Getting our bounds. So we're just going to get the extents of our bounds here. And we're going to kind of assume that we're in the middle of the bounds, but now that I'm thinking about it, that might not be the case. We're going to get the minimum and maximum of our bounds, so... There we are. And this will allow us to be able to get the values that we need. We're also going to need the center, I suppose. Just trying to make this easy on myself, and it might not be the easiest way to do it. But it shouldn't be too hard. So we'll look left, we'll look right. And this is going to be center. I guess we do just want the bounds. Center plus extents. Well, we only want the one axis, so this is where we're going to want to check for a door. How do we check for a door? Well, we're just going to go ahead and see whether or not there is a door sufficiently close to that position. That's not us, obviously. So to do that, we're going to want to just have a quick little function specifically for that purpose. I guess we can put it on the map. There's no reason for it to be on the door itself. So we'll just go through all of our doors. For each ship door, door and doors. If door equals ignore, or not door. Now this is really fun to say. Return null. Oh, no wait, sorry, this is continue. This is return null. So here we're going to say if pause, my ship door ignore. If pause minus door dot position, go ahead and put that in here. There we are. So here we're just going to go ahead and fetch the door. Here we are. If this dot magnitude is less than some small value, then return the door. Easy enough, right? And so over here in our ship architecture, what we're going to do is we are just going to ship adaptive, this one here. Let's rearrange these so I stop misclicking all the time. Here we are. So we're going to just grab the door, or I guess that's right. We'll say map.door find door check. We don't need this. Why is that underlined? Ah. And then we'll say if right, then we will clear, sorry, first we got to clear it out. So sidewall right dot for each transform t in sidewall right destroy t. We're actually going to want to do that in a slightly different way. If application dot, let's go ahead and have a function to do this now that I'm thinking about it. Void kill children. If application dot is running is playing, there, else destroy immediate t.gameObject. So we'll just go ahead and say kill children sidewall right. If right, then add the game object. So game object dot instantiate cap door mesh. No, it's side door mesh. And then we're going to want to put that at 0, 0, 0, but just in the parent. Can I just put it in the parent without? Darn it. There it is. So sidewall right. And if there is no door to the right, then we are going to want to instantiate the other mesh. But the problem is it going to be the side wall or the side window? And to check that, we're going to want to know whether or not we're to the right or to the left. So else if transform.position is greater, or position.x is greater than 0. So if we are to the right of the ship, then our right facing should be a window. Else it should be a wall. Pretty basic. The other thing we're going to do is check the left side. Let's go ahead and just call this door instead of right. Do 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 do. And this is going to be sidewall left. There we go. And that should do it correctly. Let's see if I have any errors in my code. So this is all really old log file. Here's the hallway. Let's go ahead and give it a shot. Set it up. There it goes. And you can see that it worked fine. We got the wall to one side and the windows to the other, except for the small fact that it didn't detect the door that it was trying to detect. So that means that the system didn't come back with a door. So that should have found the door to the left, but it didn't. So just to make sure that we're checking in the right place, let's go ahead and just log where our door checking is. I'll call it 0 and 1 here. We'll let that bake, and then we'll try it one more time. So we are checking at 5.9, negative 0.1, and 2.1. That's a strange offset. Oh, it's because I'm not at a good spot. Friggin' stupid moron. All right, so I was wondering why that was like that, and you can see that I've got a weird rotation as well. This all comes from being set up funny, I guess. So if I unrotate everything, but I want the local z-axis to be pointed in the correct direction. Like that. See that blue line? That's our z-axis. So then what I'll do is I'll take the right and the left and I will rotate them around the global, around the center point, which should be at 0, 0. We can correct it if it's not. It wasn't. Brilliant. So we'll just move these until they're at the right spot and round off their rotation. One of these is wrong. What? So that's the left hallway element, and it should be. But this ended up getting pointed straight down. I didn't expect that. Interesting. I must have screwed this up somehow. I'm not sure when I did this or how, but wow, did I ever screw it up. Oh, because it's not at 0, 0. It's supposed to be... I think it's supposed to be at 0, 1. What's going on? Is this rotated incorrectly in the Blender file? Is that what I'm seeing here? Because it's offset on the x-axis, and that's like the last... That just shouldn't be the case. This is fascinating. Let's go ahead and move one of the original hallways over here so that we can see what's going on. So this is the original set of hallways. It's a little bit low. There, that's the original set of hallways. Huh. This is strange. Apparently I have completely worked it. I just set these things up completely wrong at some point, and it never survived. It never recovered. Let's go ahead and try to set these up so that they're in a good position. The weird thing is they look like they're scaled incorrectly. Let's go ahead and hide this door. Blink. So basically what we've got here is this shaft is perfectly lined up with the door, and that's what it's supposed to be. It's not perfectly lined up with our test hallway though. So if we bring this down, that seems right. The interior is... There's no interior, obviously, now that I'm thinking about it. So this over here... Did I get this wrong in the Blender file? Is that what I'm seeing? I shouldn't have, because I just duplicated it, right? I didn't change anything. It's not scaled or anything like that. If we move this forward into it, it matches up perfectly. So the problem is that the fulcrum point is down at the bottom. I think what I need to do is grab all of these objects and offset them so that the fulcrum point is not at the bottom anymore. So we'll just go ahead and do that exact thing. We want the fulcrum point to be in the middle, because I think that's like 90% of what's screwing me up right now. There we go. So now that the fulcrum point is in the middle, I can get rid of these guys. They're just going to distract me. These should both be at 0, 0, 0. There we go. That's better. That's how it should look. I had an offset bug, but I don't have one anymore. It now works fine. So now that that's set up, we have to figure out why it wasn't detecting the door. And I think that it wasn't detecting the door just because it was in the wrong spot. Yeah, so now you can see it detects the door fine. It doesn't put them in the right spot, but it detects it fine. That's kind of curious. I think the problem might be that this door is rotated, but if I Alt-R, yeah, it should be fine. So, this door should be here. That's interesting. If we unmask this, you can see how the window is set up correctly. It's in the right spot. But for some reason, the door doesn't get the right treatment. This is really interesting. What's the deal here? Let's go ahead and turn this back off. Oh, that's the deal. It's not rotated correctly. Boom. So you might be wondering why they're not lined up anymore. And the answer is because this guy isn't rotated correctly. There we are. Ideal. Aside from the fact that they have really bad UV maps. But I think that's right. I think that's working. So that's what I wanted to get done today. And next week we'll go ahead and finish this off and finish with our hallway setup. I might do it off camera. There's nothing really spectacular to do here. But as you see, if I go over here and I do the same thing, it won't detect a door, and it'll give us that nice window look that will allow us to fill our ship with cool looking hallways. And if I move it up and over like this and do it again, we'll get it in the opposite direction so that the other side has the cool looking windows. That is the essence of the hallway system I'm going for. It should look great. I still need to put the other door caps on, but I don't feel like doing that right now. So I'll see you folks next time, I guess. If you have any questions, I'll be doing things for about 10 seconds, but then I'll look at the Twitch chat and make sure I didn't miss anything. All right. See you later. Oh, that's not the right button. That's the right button. Bye.